Okay, I'm trying to make the electrodynamic self-repulsive effect. This type of device, right? Let me just get straight to the subject. I've added the coil. I added aluminum tape to hold the coils into place. Before I add the rubber glue, clear, transparent rubber glue, should be industrial grade to hold the coils onto the surfaces. I add the aluminum for the surfaces so that it doesn't overheat the foam. So it's on a foam shoe. I did not put the aluminum bottom as of yet. So, and it's very much lighter than all of the other shoes, and it's not that heavy as a conventional full shoe, but it's lighter. Now, I know that this does not look exactly like Nimore, and I have to add the wings and stuff like that for the calf area. And I'm just using these sandals because I don't want to walk on the floor and just have a little buckle over, you know, some floorless sandals, bottomless sandals, and attached to some wings and a shin guard and a calf guard. No, I don't want that, so I kept the bottom just to protect my feet and also to assist in the electrodynamic force. What's going to happen here, what I'm going to be using the coils for, it might not cover it with aluminum, is to try to see if I could use it to get the coils up in the ear. It's really depending on the frequency, on how the sections. It really depends on the frequency. So let's say anything from 40 kilohertz, KHZs. So sectional voltage that is induced. So the oscillation, sonic oscillations from 40,000 kilohertz, or 60, or maybe 50, or 100,000 kilohertz. So it's really depending on how much density this has as far as the foam, and as opposing weight, along with the oscillations of the coils that releases the energy in oscillations and causing it to levitate through radiation pressure. The radiation pressure actually of the oscillations, which are in sonics, causes it to actually propulse into the ear. But to generate a densified force enough to maintain a stability, even if I add additional weight to it to be stronger than the inertial mass. This is probably going to be dealing with like measurement sensors and gravity sensors and stuff like that. So to sense actually the distance and to increase the voltage upon distance, a distance from the surfaces, the gravitized surface. So that's the idea, and I'm going to try that once. But just remember, it's not the air pressure that's going to cause it to levitate, but it's actually the atmosphere around it, at which it ionizes the air and displaces it to remove the gravitational force and the omnidirectional gravitational longitudinal frictional force that suppresses this against the weight of its gravity. That suppresses it to the weight of its gravity, which is actually 4.8 newtons of force exerting against this material in an omnidirectional longitudinal microwave. So this precession microwave has to be disrupted through oscillations, and using acoustophoresis and electrophoresis at the same time, electrophoresis and acoustophoresis, to displace the matter between the medium ions and to displace the gravitational force and to reduce the gravitational load, which is the actual 4.8 newtons of force exerted against this. So reduce it down to 1 newton or less than 1 newton, micrograms or microns of forces. As far as actually this is actually dealing with mass, so we'll deal with grams of force that is being exerted against this material to reduce that. So it's the same thing as of zero gravity freedom traveling device. So I coiled it a couple of times. I'm going to see how it works and if it functions properly.